welcome back. So in this video, I'm going to show you another example on using the partial fraction methods to evaluate integrals for rational functions. Again, we cannot evaluate this integral using any of the other methods that we have learned prior to this method. So one has to use the method of partial decomposition. But guys, let us see if this qualifies for that first type that we talked in the previous video. So again, comparing the numerator and denominator, the degree of the numerator is 1 and the degree of the denominator is 3. So obviously it qualifies for that number 1 point where we know that the degree of the numerator has to be less than the degree of the denominator. So it qualifies for that number 1 point. Guys, number 2 is that we want to have distinct linear factors of the denominator. That is something we have to verify, and if it qualifies for that as well, then we can break this rational function into different pieces. Once we break it into different pieces, then we have to see if we can actually evaluate the integral for each individual piece. And most of the times we would be able to evaluate the integral of each individual piece if we can actually break it down in partial decomposition. Okay, so let us go ahead and take this rational function and see if we can factor the denominator. Okay, so I'm going to start with the function, and guys, this guy, let us see if we can factor. Right away we can see that there's a greatest common factor x, so we can already take out that greatest common factor x, and then what is left inside? Guys, inside the parentheses I'll have x squared minus x minus 2, right? So we already factored a little bit. Let us see if we can still factor, because we are looking for, in the denominator, we're looking for distinct linear factors. We got one of them. Let us see if we can also factor this. So I will just rewrite the numerator. Guys, don't forget to rewrite things when we have to write a lot of steps. In some of the steps you just have to repeat writing things, but that is fine. We got to keep doing that. Guys, in the denominator, let me see if I can write the factors for this. Let us see. If I have to come up with two factors of -2 that add up to -1. How about -2 and 1? -2 times 1 is -2. And -2 plus 1 gives me -1, so it seems like we can come up with, so let's say I use x minus 2 and then I have x plus 1, right? So x times x is x squared, -2x plus x gives me -x, -2 times 1 is -2. Guys, I like to verify things, okay? I suggest that you should also verify. Guys, I think we have three distinct linear factors in the denominator, so it qualifies for that type 1 partial decomposition. So we can write it or break it down into 3 pieces. Why 3? Because we have 3 linear factors in the denominator. Guys, if you have watched my previous video, we had only 2 factors in the denominator, so we broke it into 2 pieces. Here I have 3 factors, so we can break it, or we should break it into 3 pieces. So it's going to look like this: a over x, okay, then b over x minus 2, and then c over x plus 1. Guys, sometimes students ask me, does this order really matter? Can I say a over x plus 1 and b over x and c over x minus 2? Guys, yes, that is totally fine, because they are just multiplied, so it does not really matter. The order here does not really matter. You can have x minus 2 here and x here and x plus 1 here. That is totally fine. Okay, I like to go with what I have here as factors, so I try to stay consistent. If I have x here, first I will put x and then x minus 2 and so on and so forth. But for some of you, like if you, instead of writing it like x minus 2 times x plus 1, if you have written it like x plus 1 times x minus 2, then you will have x plus 1 here and x minus 2 there. That is not going to change the final answer. You're still going to get the same answer. Okay, so let us go ahead and try to simplify this. Okay, so we already know from my previous example, if you have watched that previous example, what we have to do is we want to get rid of this denominator. To get rid of this denominator, the way to get rid of the denominator is to multiply by this whole quantity. But if I multiply this left hand side by this quantity, we also have to multiply the right hand side by the same thing. Correct? So let us go ahead and do it. If I multiply this to the left hand side, I will have just -x plus 5 left, right? Because this will cross out. Guys, here, let us see what I'm left with. In the first term, the x and x will cross out, so I will have a times, then I will have these 2 factors, because only x will cross out. So x minus 2 and x plus 1. That will be with the a. Then guys, with b, let's see what is left with the b. With the b, what's going to happen? X minus 2 and x minus 2 is going to cross out, right? and I'm going to be left with x times x plus 1. And then the last one is plus c. Let us see what is left with the c. Guys, with the c, x plus 1 and x plus 1 is gone. And then I'm only left with x times x minus 2. And that is it, right? Guys, I'm just multiplying this to this side, left-hand side, and to the right-hand side. Left-hand side, this just crosses out. I'm left with negative x plus 5. On the right-hand side, I have to multiply to each individual term. I multiply to this guy, x is cross out. I'm left with x minus 2 and x plus 2. When I multiply to this fraction, or this ratio, x minus 2 and x minus 2 goes away. I'm left with x and x plus 1. That's what I wrote here. And with the last one, x plus 1 crosses out. I'm left with just x times x minus 2. Okay. Then from here, goal is to evaluate or find the values for a, b, and c. Again, we are going to use an easier or like a quicker method for doing it. What I'm going to do is I'm going to try to isolate some variables, some a or b or c, and then try to solve for the others. Guys, I already can see here, if I set x equals to 2, what's going to happen? 2 minus 2 is 0. That will make this whole term disappear. At the same time, it will also make this term disappear because 2 minus 2 is again 0. 0 times anything is 0. So these two terms will be 0. I will be only left with the b term, and then here, let's see what is left here. So first I will start with let x equals to positive 2. If x is positive 2, then if I substitute that positive 2 here, it will be negative 2 plus 5, which is positive 3. On the right hand side, guys, 2 minus 2 is 0. 0 times a, and this is all going to be 0. This is also going to be 0. I'm only left with this term here, which is b times 2, which is b times 2 times 2 plus 1, which is 3. If I simplify this, 2 times 3 is going to be 6, right? 2 times 3 is 6, and implies from here, if I have to solve just for b, it is going to be 3 divided by 6, which is 1/2. So I have my value for b. At least I have one of the values. I still have to find the value for a and c. So let us see how we can find the value for a and c. Let x equal to, how about if I set x equal to 0? Because I'm looking at this. First I was looking at this because I already have my b, so I don't care about if I lose or if b is vanished. So if I set x equal to 0 here, my b is vanished. Well, in this case also, it's multiplied by with x. So if x is 0, even the c will go away. I mean, this whole term will go away. B will go away, this whole term will go away, but this won't go away, so I will be able to evaluate a. Okay, so let's go ahead and set x equal to 0. So guys, once you set this up, then basically I'm looking at this right hand side, and then from there I'm deciding what values should I choose or pick for x so that I can isolate or eliminate some of the variables or some of the terms and solve for the a, b, and c's. Okay, let x equal to 0. If x equal to 0 on the left hand side, it's just going to be 5. On the right hand side, this term is 0, this term is 0. This is going to be a times 0 minus 2 is negative 2. 0 plus 1 is positive 1. What does that imply? That implies a equals to negative 2 times 1 is just negative 2. So a would be negative 5 over 2. That is a, that is b. I still have to evaluate the value for c. A and b are done. Okay. Now to evaluate the value for c, this is what I'm going to do. Guys, I just realized looking at this term and this term, if I set x equal to negative 1, if I set x equal to negative 1, I'm going to lose this term. Okay, this is going to become 0. If I set x equal to negative 1 here, I'm going to lose this term. I don't care because I already have a and b. I don't care, I don't mind if I lose those two terms. But this, I'm not going to lose this one, so I will be able to evaluate the value for c. So that's like just a clever technique of evaluating a, b, and c, or any constants that we are trying to evaluate by doing this partial decomposition. So let us see where I can find more space for that. Maybe I can do it here. So what do I have here? I'm going to say let x equal to negative 1. If I set x equal to negative 1, guys, this is going to become negative times negative is positive. 5 plus 1 is 6. 6 equals to, this term becomes 0, this term becomes 0. I only have c times negative 1, and then I have negative 1 minus 2, which is negative 3. And if I simplify this, guys, negative times negative is positive, so it's 3c, right? Because they are multiplied. and from this I have c equals to 6 divided by 3, which is 2. Guys, I have a, I have b, I have c. Let us put it all together and then let us evaluate the integral. So I can write this down into 3 pieces. I don't know why my integral was so ugly. Let us try to draw another integral. Okay, I think this was better. So this is a over x. What is a? Negative 5 over 2, negative 5 over 2x. That is my first term, dx, plus integral b over x minus 2. B is 1/2, so 1 over 2, and then x minus 2, and then dx, and then plus this last term, which is c over x plus 1. What is c? C is positive 2. So it is 2 over x plus 1. Of course, there's a dx. So we have 3 terms, and I think we know we can evaluate the integral for this term, these 3 terms. So let us make some room and write the final value for this integral. So guys, this value, the first one would be, you can just take out negative 5/2. It is just integral of 1 over x. Guys, I'm going to write all the steps. From here, if you can already see what is going on, that's fine. You can skip some steps, but I will write all the steps. And then the last one is, I'm going to take the 2 out, and then it will be 1 over x plus 1 dx. Okay, I just took the constants out. Now, from here, this is the constant still is outside, and we know the integral of this is just simply ln of x, right? And all of them are the logs, natural log. So 1/2, and this is also natural log of x minus 2 divided by the coefficient of x, which is 1, so we don't have to really write it. And then finally, this is plus 2 times natural log of x plus 1, and then of course a plus c. Guys, this is the final value for the integral of this function, but we had to break it down using the partial fractions or partial decomposition method, and then evaluate the values for a, b, and c, bring it all together, use the basic identities or basic formulas, like the integral of an inverse function is the log, and then we can write the integral. Okay, so guys, this was still type 1, but it was another example where we had 3 factors, 3 distinct linear factors in the denominator. In the next video, guys, I'm going to show you type 2, when we may not have distinct linear factors, we may have something that might repeat. So how do we break it down into partial fractions? We'll see in the next video. Guys, till then, take care and keep practicing these examples.